My name is Slurm, and I'm the technical lead on the EcoCommons platform team. So I'm based at Griffith University at the Gold Coast campus. So I work here with a team of amazing developers that are currently developing the brand new platform, which is currently undergoing internal testing and getting ready for external testing in the very near future. And today I will be talking about how we are running reproducible workflows on our platform, and I will be specifically focusing on the workflow execution and the tools we are using around this. So let's get started. Okay, let me just get myself out of the way first. There, much better. Okay, so what are we trying to achieve with the EcoCommons platform? So we want to provide access to trusted and curated datasets. We want to provide access to a catalog of trusted models and workflows, and we want to enable the users to create and execute reproducible workflows that can be shared, reused, and improved over time. So this is not the full picture of what EcoCommons platform actually delivering, but it will be the focus of this presentation, as we'll be focusing on the workflow execution and the usage of Nextflow to produce reproducible workflows in a cloud environment.
What were our requirements for workflow execution? Well, first off, we needed the workflow execution to be reproducible. So this means we needed to be able to predictably rerun a workflow that would process data in the exact same way each and every time. This was a core requirement for us and a non-negotiable. Secondly, our workflow execution needed the ability to handle both simple as well as complex workflows. So we needed the ability to start out simple, and then as we got more complex workflows, we needed the system to be able to handle this seamlessly. Third, we needed it to be scalable. So that means that we would want to be able to run it on multiple or separate clusters if necessary and scale out to handle lots of concurrent jobs. In the beginning, this was not an issue as we were just doing simple testing, but we needed to future-proof the platform so we knew that it could handle a great increase in usage if necessary. Fourth, we needed it to be infrastructure agnostic. So this means that we needed the workflows to be able to run basically anywhere, as we did not want the functionality to be tied up into specific infrastructure setup or providers. We also wanted a method that was stable and battle tested. So we didn't want to start off with something that was completely new and hasn't been tested in the real world. So we wanted to go with something that's already being used in high volume production systems, so with similar use cases to what we had. And last but not least, we wanted the ability to do local testing and prototyping easily. So this is actually a really important requirement as it enables multiple collaborators to easily come in and contribute to the workflow development. And in a project like EcoCommons with several invested partners, this is a really high priority requirement for us. So what is reproducibility? One of the key deliverables of the platform that runs scientific workflows is the ability to reproduce a specific workflow. So I wanted to quickly go a little deeper on reproducibility before we proceed. So in a single sentence, reproducibility is the ability to exactly recreate an earlier research or analysis given the same data. So meaning that if I give you a list that describes all my method for a research and the input data, you can make the exact same findings as I did. So the image here is the reproducibility spectrum, and showing the range from research as described in publications all the way through full replication, which is the gold standard. And at EcoCommons, we are attempting to get as close to the full replication wherever possible. So we're over to Nextflow. And what is Nextflow? So Nextflow is data-driven computational pipelines. So Nextflow enables scalable and reproducible scientific workflows using software containers. It allows the adaptation of pipelines written in the most common scripting languages, and being scalable, reproducible, and using containers, that really ticked a lot of boxes for us. So as you see in this little diagram here on how Nextflow works, it utilizes the integration to Git code repositories, using software containers like Docker, and then using that to produce these reproducible workflows. So from the start, it looked like a really good fit for what we wanted to do with the EcoCommons platform. So to go a little deeper on Nextflow, I'm gonna talk a little bit more about some of the features on Nextflow. So fast prototyping, as I mentioned before, that's something that's important to us. And Nextflow allows you to write a computational pipeline by really making it simpler to put together many different tasks. So you may reuse your existing scripts and tools, so you don't need to learn a new language or API to start using it. You can use what you're currently using to run your workflows. Reproducibility. So big one, Nextflow support Docker or Singularity containers. And this, along with the integration of most Git code sharing platforms, allows you to write self-contained pipelines to manage versions and rapidly reproduce any format configurations. Not a big tick for us. Portable. Nextflow, it provides an abstraction layer, so it can actually be executed on multiple different platforms without ever changing the result. So it provides out-of-the-box executors for things like Grid Engine, Slurm, LSF, PBS, Moab, HTC Condor, and batch schedulers for Kubernetes, Amazon, AWS, Google Cloud, and Microsoft Azure platforms. So again, this was a very important part for us in order not to lock us into a specific infrastructure setup. Continuous checkpoint is the last part I want to focus on here. So Nextflow stores all immediate results during the pipeline execution and automatically tracks them. So this allows us to resume its execution from where it last successfully executed step. So no matter what the reason whether it was stopping, whether it was running out of memory, whether something was wrong, no matter what, you can rerun it from that point on. That also allows for a smarter rerun of your workflow. So if you run your workflow and then realize you want to tweak a couple of parameters and then run it again, Nextflow is actually smart enough to figure out which tasks it needs to rerun and only run these. So that will save you time and also resources. What's this? This is the EcoCommons platform. So it's a high-level view of the EcoCommons platform. So as you can see here, we have three major clusters inside the platform environment. So we have an application cluster, we have a Jupyter Hub cluster, and we have a Slurm execution cluster. So the application cluster runs on Kubernetes, and it contains components such as the function catalog, analysis playground, result manager, data explorer, data manager, job composer, job manager, and more. So the backend services are written in Python, and the front-end services are written in Next.js and React. Next one is Jupyter Hub cluster. So this is also running on Kubernetes, and this powers our coding cloud component, and it allows users to spin up their own Jupyter Hub notebook with a pre-configured environment where they can utilize packages and set up from different languages such as Python, R, Julia, etc. The third cluster is the Slurm cluster. This is where we do the job execution. So this is what basically we're focusing most on in this presentation. But here we are running Slurm as the scheduler, and we have Nextflow and Docker to utilize for the execution of the workflows. In addition, we have separate virtual machines running services like database, authentication, and Elasticsearch. In addition, we have object storage, and everything of this is running currently on the Nectar Research Cloud. So if I'm referring back to the earlier slide where I pointed out some of the things we wanted to achieve, here's how we are solving these at the moment. So provide access to trusted and curated datasets. This is solved by the Data Explorer, linking curated datasets and external datasets via API connections. Provide access to a catalog of trusted models and workflows. This is solved by function catalog and modeling wizards, enabling the users to access trusted models and workflows in an easy-to-use environment. Third one, enabling and creating and executing reproducible workflows that can be shared, reused, and improved over time. This is solved by our job manager and execution engine that utilizes Slurm, Nextflow, and Docker to produce scalable and reproducible function execution. All right, it's time for some details. So let's get into the details and how are we running workflows on the EcoCommons platform today? Let's have a look. So how we run workflows. This is a brief overview of the process that we go through on the platform to run a simple species distribution model, or a SDM function. So here you see the different components and the different steps advised from the user submitting the experiment and going through the API through to execution and storage of results and back to the user where they can explore it through the result manager. So let's look a little bit deeper into each of those steps. First point is create a job. So when a user designs an experiment using our modeling wizards or function catalog, a job request is sent to our internal job manager API. And this job request contains all metadata needed to run the experiment. So this is input data, constraint parameters, algorithms or models to run, plus more. So this is submitted to the API, it's stored there, and then it's then distributed to the Slurm cluster for processing. So let's have a look at that. So this is the part where the Slurm cluster is actually being invoked. So the job manager API packages the job needed to be executed, sends them to the Slurm cluster for processing, and Nextflow is invoked to run each job or pipeline. Next step, the weblog. So the weblog is a feature of Nextflow where during execution, it can send a HTTP request with task progress information back to your system. So in our setup, we direct Nextflow to send all status updates back to our job manager API, where we link it with the initial job record and update the status of the job appropriately so that we can show that to the user. And the weblog also comes with the benefit of actually producing trace material. So the trace material from Nextflow is status of the resource consumption by the different tasks. So you can get information of how much CPU, memory, disk, etc. that the tasks are using. So this is really useful. So SDM functions, inputs and outputs. So here we are describing a simple SDM function that's being run a pipeline on Nextflow. So we have the first process where you download the data. So this is where all data is prepared and made ready for actually running the function. Second process is running the function, uses the data that was provided and downloaded and utilizes the parameters supplied by the user. And the last part of this process of the pipeline is actually uploading the results produced by the SDM function. So it uploads this into the Swift object store. And after upload to Swift, we register the result back, updates the job record, and link the result set back to the original job so that the user will have full access to this once they go through their user dashboard and browse the results, and they can view these results in the result manager component inside the EcoCommons platform. And all this is, so all access directly to Swift, which is the object store, where all results and user data is stored. It goes through our APIs that authenticates the user and authorizes them to what kind of content they're available to access. Lessons learned. There are many, but here's a few. So look for solutions and tools that allow flexibility and follow standards. Words like common and generic, they're not actually bad traits when you're building a platform. For example, Nextflow natively uses Docker and Singularity containers, integrates directly with Git repositories. All these are really common things, but it fits right into our existing tools and workflows. Second point is agree on data input-output structure early. So when dealing with workflows and results, it's important to determine the data I/O processes early on. Otherwise, if you end up without that structure, you have no common data handling for the workflows. It means problems that are a lot harder to debug, and data access issues and things like that may also arise. And third one, capture process feedback. So start collecting stats right from the start so that you can inform your improvements and optimization with actual data. So I call it here, embrace the trace. And Nextflow offer task level stats for CPU, memory, and disk usage, something that he calls its trace file. Use these to optimize your workflows and compute. You know, the ability to just do a SQL query to see the average CPU, memory, and disk usage for a specific algorithm is really powerful, and it really can help us improve where we need to improve and optimize where we need to optimize. Interesting today. So shortly after this, we have Mr. Paul Tudman introducing the world's first biosecurity virtual lab with our sister project, the Biosecurity Commons. And then later we have Dr. Robert Clemens, who's going to be exploring the EcoCommons path for impact and sustainability. All right. Thanks so much for listening to me today. It was a real pleasure to present to you. Thank you.